So let's review really quickly the law of sines. So the sine of A over A equals the sine of B over B, or if you wanted to, it also equals the sine of C over C. So if I have a triangle, when can you use the law of sines? Well, not quite everything. So we can use the law of sines for angle, side, angle. Angle, angle, side. Side, angle, side. And angle, side, side. But there's a catch on that. If you're solving for angle, side, side, then you have to be careful because the triangle might not exist, which means you get a ratio that's outside the range of the sine. You get a number bigger than 1. Or if the angle you find is bigger than the angle that was given, then you end up having to do two different answers. There are two triangles. But if the angle you find is smaller than the angle you were given, then you're guaranteed that the triangle is going to work once. So notice, you either need two angles and a side, or two sides and an angle. There's something obviously missing from that group. Side, side, side. You cannot use side, side, side. How come? Right, if you use little a and little b, you need at least one angle to find the missing side. So, remember when we did that little trick where we called this h, and then we did b times h divided by 2, and we ended up with this law of sines? You can do the same thing with law of cosines. It's a little bit more complicated. For the sake of time, we're going to not do it, though. I'll show you what the formula is. So the law of cosines says c squared is equal to a squared plus b squared minus 2ab cosine of c. Now this applies to all triangles, not just right triangles. And we can actually convert the formula to involve any particular side we want. So if I were to change it up and say a squared, what would that equal? B squared plus C squared, and again, those commute, so you could change the order of B and C if you wanted. Minus 2BC cosine of C. Or B squared equals A squared plus C squared minus 2AC cosine of, oops, that was supposed to be cosine of A, and this is cosine of B. So when is this going to work? Side angle side. So what are the three variables here? What three structures are we looking at in this equation? Well, we see three sides and one angle. Well, I mean, the formula involves three sides and an angle, right? So we can leave out any one of those. So we could do side angle side. What else? We could do angle side side provided what? Provided we know there's only one solution. So we're going to leave that off because the law of sines is a better way to deal with that than the law of cosines. What else could it do? It could do side, side, side. If you know three sides, then you can find the missing angle, which is something that the law of cosines will not do. Or sorry, the law of sines will not do. So let's do a side angle side problem because those are the easiest. So we'll start with the easy part. So if I had a triangle, A, B, B, C, and C, and I said that side C was 18 feet and angle A was 25 degrees, and side B was, oh, I don't know, 10 feet. Using the law of cosines, what can we solve for? A, little a. That's all, that's the only option for solving. So if I'm going to solve for little a, which formula do I have to pick? The second one, how come? Right. This is the only angle I know. So I have to use the middle formula because it's the only one that uses angle A. And then the formula is just plug and chug, basically. A squared is unknown equals 18 squared plus 10 squared minus 2 times 18 times 10 times the cosine of 25. I ran out of room. Plug that in. 18 squared plus 10 squared minus 2 times 18 times 10 times the cosine of 25. So 97.72, what does that tell me? That's a squared. So a squared is 97.72. So all I need to do is raise it to the 0.5. So little a is 9.88. Okay? Well, what if it asked me to solve the triangle, which means find all the missing parts? How would I find angle B? I'd use the third equation because that's the one that has the cosine of B. So I'm going to erase the top two equations. Get rid of those. And we now know little a, so we can fill it all in. 10 squared equals 9.88 squared plus 18 squared minus 2 times 9.88 times 18 times the cosine of b. Everybody okay with that? So I'm going to subtract these over. 10 squared minus 9.88 squared minus 18 squared. So I have negative 321.614 equals negative, oh, what is that? So negative 2 times 18 times 9.88. Negative 355.68 cosine of b. Now what should I do? Divide. So negative 321.6144 divided by, oops, I missed a number. Divided by the answer. And I get the cosine of b equals 0.904. So now I simply invert the cosine. So angle B is 25.28. And then you do 180 minus 25 minus 25.28. So it's going to be 129.72, somewhere close to that. Okay, well, that was kind of awful, right? That was no fun. So, in my opinion, You only use the law of cosines when you're looking for an unknown angle and you have all three sides. It would have been a lot easier to use the law of sines to find b. Would you agree? Would have been a lot easier. You set up the two fractions, you cross multiply, you divide, and you're done. Well, and then you invert. You divide, then you invert, and you're done. So the law of cosines is kind of nasty in that regard, but something funny can happen with the law of cosines that doesn't happen with the law of sines. So I want to point that out. Let's do on your worksheet. Look at number 7. I think that's the one that it happens on. Yeah, I did. Wait a minute. Yeah, that's it. Okay, so if we're looking for angle A, we need to use the a squared equation. So 14 squared equals 9 squared plus 6 squared minus 2 times 9 times 6 times the cosine of A. Everybody okay with that? Well, notice when you do 14 squared minus 9 squared minus 6 squared, we end up with a positive number, which didn't happen last time. So 79 equals negative 108 cosine of A. So I'm going to divide by negative 108, and we get a negative value. Is that possible? Well, we never got a negative sine value when using the law of sines. The reason is, if you remember the graph of the sine function, it looks like this. So from the sine is invertible from 0 to 90. And all of those values are positive. But the cosine graph is a little different. Cosine graph looks like this. And it's invertible from 0 to 180. Notice if we went all the way to 180 on the sine, it fails the horizontal line test. Okay? But the cosine, that's not true. It's invertible from 0 degrees all the way up to, from 0 to 180. And notice, if you go beyond 90 degrees, then the cosine is going to be negative. And if you look at that on the unit circle, remember, sine is the y value and cosine is the x value. So the cosine is invertible from 0 to 180, and in quadrant 1, the length of the ground is positive, but in quadrant 2, the length of the ground is negative. So sometimes in the law of cosine, the ratio you get will be negative, which means it's in quadrant 2, which means that the angle is bigger than 90 degrees. But the nice thing is the calculator understands this for you. So if you invert the cosine, it will just give you that obtuse angle. So if you're finding an angle of an obtuse triangle, and more specifically the obtuse angle, then your cosine value is going to be negative. Okay, well, this formula looks really similar to another formula we know. Did anybody notice that? What does that look like? Looks a lot like the Pythagorean theorem, right? Well, the Pythagorean theorem applies here. So this is the trouble. That's the difference. But if we look at the unit circle, in a Pythagorean theorem, how big is angle C? In a right triangle, what's the angle C? It's 90 degrees. The way we label a right triangle is always C goes there. Well, at 90 degrees, So that's 0, comma 1. What is the value of cosine? 0. So if this is a right triangle, then this value is a 0, which means negative 2 times whatever times 0 is 0, and this disappears. So the Pythagorean theorem is actually a special case of the law of cosines. It's the case where the angle you're looking at is a right angle, in which case the negative 2ab cosine c drops out. Now, Pythagoras didn't know that. We found that out later, but it's just a specific case of the law of cosines. If you look at the last page, I don't care what method you use. In fact, I would prefer that you be a little smart about this. So, number 13, are you going to use law of sines or law of cosines? I would use the law of sines. It's actually pretty easy to find little c using the law of cosines. The law of cosines works really well for side angle side. That's not a problem. Okay? So if you want to use law of cosines there, it's easy. You plug it in, you take the square root, and you're done. But would you use the law of cosines to find A or B? No. Not unless you absolutely have to. Are there any problems where you have to use the law of cosines? 16 would be one of them. Any others? What about 19? 19 is yes, how come? Doesn't give you an angle. 22 has no angle. 21 has no angle. And so on. Okay? So I don't care what method you use. Side angle side isn't too bad, but only use the law of cosines for an angle if you have side, 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 and nothing else. Okay? You'll probably get close to finished today. Would you like to see the answers? I do require that you write down the initial equation. So if you write down the original, not the A, B, C, but if you plug the numbers in once and then you do the rest of the work on your calculator, I'm happy. Does that make sense? Let me back up and... So, for example, if you show me that, and then you do the rest in your calculator, I'm happy. Okay? All right. Have fun. Good luck.